Welcome everybody to Calculus BC. In this video, I'm going to be finishing up chapter 9.2 with something called the divergence test. So I apologize, I forgot to include this in the last video that included all of the telescoping and geometric series, but this is going to be our first actual test of whether or not a series just diverges, and it's called the divergence test. Sometimes other books, and actually most books, will call this the divergence test, or they'll call it the nth term test. And one thing that we want to make sure that we're very clear about when it comes to the divergence or the nth term test, all it does is it tells us whether or not a series will diverge. So let's write that down. This test tells us if a series diverges. Here's what the test doesn't tell you. It does not tell if a series converges. So it's really important to keep that in mind because there's going to be a condition that needs to be met in order for the divergence test to show divergence. If this condition is not met, you know nothing else about the series. So let's just make sure we are very, very clear about that idea. And so basically what it does is it says, I'm going to take the limit as n goes to infinity of the sequence in question. And if this sequence does not become zero, what we know about the series is that the series definitely diverges. The other condition is that if I take the limit as n goes to infinity of a sub n, if I do in fact get zero, we don't know anything about it. So nothing else known. Because we have seen sequences in the past whose terms approach zero, but the series themselves do not approach zero. And I will show you that example in just a little bit. So give me 1 second here. Let me go ahead and show you guys a couple of examples here. If I'm going to start off with this series here, the sum from n equals 1 to infinity. Pretty easy coming out the gate example here. So n squared over 5n squared plus 4. If we were to take the limit as n goes to infinity, right, we're trying to find out the sum. So that would be the limit as n goes to infinity of my sequence generators. That's going to be n squared over 5n squared plus 4. Well, that gives us 1/5, right? If we take that limit. Now remember, back in sequences, we determined that the limit of a sequence would tell us what the terms were becoming. So what's happening here is that the terms are becoming 1/5, 1/5, 1/5, and dot, dot, dot. Now that's what the terms are becoming. And while this sequence converged to 1/5, remember, we're not doing sequences anymore. We're in series. So what's really happening to this series is that as n goes to infinity, you're getting 1/5 plus 1/5 plus 1/5 plus 1/5, dot, dot, dot. And as you add 1/5 to itself an infinite number of times, this dude absolutely diverges. So what we say about this is that 1/5, so we can say, 1/5 does not equal 0 and therefore diverges by the divergence test. Now, one of the things you're going to want to start getting used to as we move forward into the convergence tests in series is knowing their names, because you're going to want to justify how you proved convergence or divergence based on the test's name. So this would be the answer that I would be looking for. So from here, again, there's not a whole lot to the divergence or the nth term test. We're going to take a look at another. Series here from n equals 1 to infinity of 1 over n. And if I was to expand out the first few terms, it would be 1 over 1 plus 1/2 plus 1/3 plus dot, 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 right? And what's happening here is if I take the limit as n goes to infinity of 1 over n, I get 0, right? And so it's easy to think, okay, because the terms approach 0, that means that our sequence is approaching 0, which means our series should approach 0, right? However, I want to give you some caution here. This is but I want you to think back to impropers real quick. Think of this. And we're going to cover this in more detail in the next video. What happened to this integral expression right here? And remember, an integral is simply the summation of area, right? So its behavior is very much in tune with a series that is a summation of a bunch of terms. And so this guy definitely did something kind of odd. And so that means that even though this divergence test proved that the sequence of terms goes to 0, we don't know necessarily that this series would approach 0. So we don't know anything. So therefore, by the divergence test, we know nothing. Now, you wouldn't write that down. In fact, you probably wouldn't even use the divergence test on a series that looked like this. In the next video, I'm going to show you what test I believe is best for this particular series. It actually has a name. And so we will get into that in the next video. But for now, I wanted to give you guys just a preview into the divergence test. And I apologize for leaving it out of the last video. But as always, please leave comments or questions in the comments area. And I will see you all in the next episode.